So first off, thanks all for joining on today. I hope that your session two classes are all um, doing good, not too rough for you yet. Yeah, so first, just a little quick introduction on me. I noticed a couple of you I've had before, so welcome back. But my name is Summer. I have been with the Jackson College now, oh gosh, going on 3 years. I've been full time only since October. So prior to this, I was just an adjunct. So I just did classes on the side. And then I worked um, for the state of Michigan as a water engineer. So that's my background is in environmental engineering. That's where I have both my bachelor's and master's degrees from MSU in. So that's kind of how it relates to this course, just because, engineering, a lot of the applications, electrical knowledge is a big portion. So yeah, but my, I guess, area of specialty is in water. So drinking water in particular. So I kind of oversaw 26 water systems for a couple of years when I worked at the state, Jackson included. So if you have any questions about your drinking water at Jackson or anywhere else you live in the state, I might be able to answer that along with hopefully some electrical questions as well. But yeah, so I guess today I just wanted to kind of talk through ELT 106, talk through this course. If we have time at the end, I'll go and kind of discuss a little bit on competency A. But if you haven't already been in Canvas and seen that this is a CBE style course or competency based education course, you're hearing it now. So it's definitely an interesting um, course, I guess, setup, but I think that there's a lot of benefits to it. And just for any of you that are kind of maybe starting out in the electrical courses and working your way up, a lot of the courses are going to transition to a CBE style you'll see in the future, and many have already, such as 106. So basically what CBE is it stands for competency-based education. In a competency-based education course, it's a big movement right now in higher education. Essentially what it means is instead of getting assessed and getting taking a final exam that's worth your whole grade and getting a 70 on it and having a C in the course. Instead, this course, essentially the goal is you need to or you should master all competencies. So what I mean by competencies is those are like the objectives from the course of what you should be learning. And essentially, the way to master them is to continually practice them. So, with that in mind, there's a final project and a final exam requirement of this course, and you have to get 100% on it in order to pass this class. It sounds intimidating, but it's not, because you have multiple attempts. You have unlimited attempts on the quizzes, unlimited submissions on the project that I will continually grade just until you essentially get everything correct. And the goal there is if you get everything 100% correct, that means that you've mastered all competencies, which is, it's definitely crucial for these trades courses because, if many of you go on to be electricians or go on to be line workers, especially when it comes to, some of these topics and safety and just electrical knowledge, it's not good to just have half the competencies mastered, right? So like, does a C in a class mean that you are equipped to move on? So probably not, right? So the idea here is that you continually work until all competencies are passed. But yeah, so it really shouldn't be too stressful though, because again, I'm here to help you throughout the whole way in the next 7 weeks. I'll be on here every single Wednesday, 5:30 to 6:30, to talk through some of the project questions, talk through everything, answer any questions. But yeah, so I'm going to kind of dive into the final project, the final exam, the syllabus, the grading, all of that. I'll talk about attendance here in a minute. But before I do, sorry, I've been blubbering now for a good 5 minutes. So just going to give you guys time. Anyone have any questions, concerns, anything at all they want to ask up front?
Questions?
Yeah, go ahead, Jared. I see you're talking. Any question? I don't know if it doesn't, it looks like I can't hear you anymore, but if you have a question, feel free to ask it now. Or if you want to save it for that, that's fine too.
I got a question, but
Yeah,
I gotta look at what they're called. You know those modules? They're
the
not like
amateur modules.
yeah. So for
Mhm.
those, do we have to score 100 on those also?
Nope, good question. I'll talk about that too. So the amateur modules, everything in Canvas is essentially practice. So I strongly encourage you to do those modules because they're going to be helpful in answering some of the project questions and the quiz questions. But at the end of the day, no, they won't be graded. You'll see them in the grade book, but their only thing that's graded for this class is the final exam and the final project. The other kind of benefit here is if any of you have extensive background in, electricity or in the concepts that we learned through this course, it should be less work for you because it means that you've already mastered some of the competencies. So that's, I guess, another good thing is there's not a lot of busy work, right? It's you answer everything, and if it's correct the first time, you're good to go. So yeah, hopefully that answers your question.
Thank you.
Of course. Any other um questions before we get started? There'll probably be more, I imagine, if I talk through Canvas, but if not, I'll keep going. All right, not hearing anything, so feel free to interrupt me at all, or I I'll stop whenever there's questions. So okay, so you should all have access to Canvas, and I'll probably kind of give a quick rundown on how Canvas works, just because I don't know how many of you have taken an online course before, and I know it can be pretty intimidating if you have not taken one. So essentially, this is Canvas. Um, you can see your courses here. If you click on this tab, you can see I have a lot because a lot of classes right now for myself. So you can, click on whatever class you're trying to toggle to. This is ELT 106. You can see that's the one I'm in now. So this is a 7-week course, which means it goes pretty quickly. And the last day of this course, I believe, is May 3rd, which is a Friday. Technically, I would have everything complete by May 2nd. So that's what this is telling you. This is just a Zoom link in Canvas. All of you are on it. So I imagine getting to the Zoom course was not complicated for you. So a couple other things you'll see here in this Getting Started tab. Please make sure to take this Getting Started quiz. That is the other requirement. But it's technically not graded because it's you shouldn't get anything wrong, but it's just basically having you acknowledge that you understand how this course works. Please do that today if you have not. It should take you just a couple minutes. So this link here takes you to the textbook. The textbook is a good resource. I don't think that you have to sit down and read the whole textbook. If you are like that and that's how you like to learn best, go for it. That's how I learn best, at least. But it's just there as a supplemental resource. This certification information talks about the MSSC certification exam. So essentially, to kind of briefly touch on this, you'll have this requirement in a couple different courses here, like in the manufacturing and trades area. Essentially, there's something called the Certified Production Technician assessment, and it's a 4-part assessment. I think there's one in safety, one in maintenance, one in, what are the other? Production, maybe, or qualities. There's a couple different like assessments, like in different categories related to manufacturing. And it's highly encouraged that you take these because if you pass all 4, you basically get the certified production technician certificate. And that's just a good like resume booster, a good thing to kind of talk about in job interviews. But again, you have to pass all 4 portions of the exam. So in this class, you have the option to take one of those assessments. I think the one you would take for this course is the maintenance one. You can see here it says maintenance awareness assessment. You should get an email from the testing center, I assume in the next couple of weeks. But I see that maybe it is I'm going to fix this note because I see that this is an old note because it's talking about 2021 and that's old. So it isn't required. I know it says required here. I'll change that today. So I apologize if that confused any of you. So it's not required, but it's encouraged to take the exam if you want to. It's kind of part of this class at the end. So that's the only thing on that. And as we get closer to the end of the course, I'll talk more about like some resources to help you study for that if you do want to take it. So that's what that certification information is talking about. Again, MSSC certification. If you have to take it for a couple other classes you're in, it might be beneficial to take the maintenance one, because if you pass all 4 again, you get a certificate. Okay, so this tab here talks about competencies. These are the 4 competencies for the course. So competency A and B kind of go together. We're going to talk about basic electrical theory, electrical control, safety, and circuit wiring. So basically an introduction to electricity. So we're going to talk a lot about that in the next couple of weeks. Competency C is about hydraulic and pneumatic theory, and competency D is about foundations of industrial automation. These are the 2 that kind of relate to the manufacturing side, maintenance side, things like that. So that's kind of how the course is laid out. That's what it's about. And then grading, because I know that's a big one everyone's curious about in a CBE class. Essentially how grading is going to work for this course is if you get everything correct on the required exams, so there's 4 parts of the final, and all sections correct on the final project, which again, you get unlimited attempts, unlimited submissions. You will get a 4 point in this class. If you make an effort to complete the final exam or final project, but are missing even 1 point, you'll get a 1.5. And if you make no effort, you'll get a 0. So with that, that's the only thing that's kind of, I hate about these courses. It's, I love taking or teaching a CBE course. I think it's all in all like a great kind of agenda that we're moving in. But the only thing I fear is that like if someone doesn't understand the requirements and like gets a 14 out of 15 on the project, technically I have to give them a 1.5. But the way it's outlined, and I hate doing that because it's just, kind of goes against like everything that you've had previous courses on. A 14 out of 15 would never be a 1.5. It'd be probably a 3 point, right? So that's the only thing I just really want to emphasize here is that you have to get 100% on the required exams and the final project in order to get a 4 point, or in order to get anything but a 1.5. So basically you only have 3 grading options that you can get. You're either going to get a 4 point, which hopefully all of you do. That's the goal. You're either going to get a 1.5 or you're going to get 0. There's nothing else in between. But again, like, I know it sounds intimidating, but my objective is to have every single one of you hit these competencies and make sure that you all get a 4 point. So it should be encouraging, right? Like, and hopefully get a 4 point. And I think it's, a couple credits of a class. So it's going to be weighted heavily than, like a 1 credit course. So a 4 point will really boost your GPA. Okay, so this is also important here, this pacing guide. There are no due dates for this course. I do this for a couple of reasons. One, because I recognize that many of you work, many of you have families, lives, a million other classes, and this is an online course at the end of the day. So there are no deadlines for like every Monday you have to have this amount done. Because I recognize some weeks are going to be busier than others over the next 7 weeks. But in general, you need to follow this pacing guide. If I see that you're kind of lagging really behind, please reach out to me, because I have to take attendance every single week. And if you're not doing any work, I'll assume, or not emailing me or not attending these, I'll assume that you're not enrolled anymore, and I'll probably mark you as like no attendance. And if you have 2 no attendances in a row, it automatically drops you. So with that, it's really, really important to either be communicating with me weekly, attending these weekly meetings, or just make sure that you're submitting some quizzes so I can see that you're still enrolled, and that's every week. So please make sure you're doing that. But that's also important to mention now that I just mentioned attendance. So for this course, this first one I make mandatory because I just want to make sure we're on the same page. You guys are on the same page. You know who I am, you know my contact information. But going forward, these meetings will only be, like they'll be optional. So you don't have to attend, but I highly, highly encourage it because I'll be here to support you, to answer any questions. But also with that, if there's ever a time where you want to meet individually to talk through like maybe your project and some of the questions you got wrong, or talk through maybe some questions on the quiz that you don't understand, you can either bring them to this and we'll talk about them as a whole, or we can meet individually. So I'm happy to meet with any of you individually, fitting your schedule best. So again, I know some of you work first, second, third shift. We have to meet at 5 in the morning, 10 at night, whatever we have to do, whatever works your schedule, that's what I'm here for. So yeah, I can set up individual Zoom meetings. I think I have a Calendly link in Canvas where you can schedule office hours with me. But if none of those times fit, send me an email and we'll find a time that works. I'm also on campus on Tuesdays usually, or any other day. I can make work, go to campus and meet in person. So yeah. So again, this is just a pacing guide for every week in general, what you should be doing. But before I get too far into this, I've been talking for a while still. So and I've thrown a lot of information at you. So just gonna pause again and see any questions so far about attendance or the way you're gonna be graded. All right, not hearing anything. I'm really hoping all this is clear and I'm not just totally confusing you or throwing too much at you. I tend to talk fast, but yeah, so please, if I need to slow down or repeat something, speak up and, and tell me or throw it in the chat. Okay, so week one, that's what we're on right now. We're about halfway through week one. Basically, just a couple of things you should be doing for week one. Read through the course information, which we're kind of going over today. Take that getting started quiz, read through the final project, which we'll talk about in a minute. Sign up for the CPT exam if you want to take it. Download the template for the final project. Again, we'll talk about the final project in a minute. And then start working on the lessons in part A, or what that means is competency A. So those are lectures 1 through 8, and there's a couple of amateur modules that talk about electrical circuits, electrical voltage and current measurements, and resistance that are all, very relevant to passing that portion of the project and those portion of the quiz questions. So with that, we'll kind of get started talking about the exam and the projects and going through the rest of this. So there's a couple of course tips in here. And then the syllabus is also under this getting started. So to kind of open that and just talk through a couple of things, should be pretty straightforward now of everything we mentioned. So here's my contact information. If you don't have it, hopefully you all do, but want to send me an email. So I'm going to throw that in the chat for you. And feel free to email me any hours of the day. I have a baby, so I'm up just about any hour of the day. So sometimes you'll be surprised if you send me an email at 2 a.m. I might get back to you within the hour. So don't worry about that. So if you ever have a panic in the middle of the night and forget something and have a concern about your grade, you still might get an answer then. Okay, so we're going to start with the competencies a little bit. So again, these are just the course objectives for what you're supposed to learn in this course. There's no textbook required. Grading procedure, we already talked about. It's you either get a 4.15 or 0 point. So that's why the syllabus looks a little goofy, because there's no option in between. The rest of this is pretty straightforward, so I'll let you read it on your own. Again, as of attendance, please just make sure you're communicating with me once a week, attending these, or logging on to Canvas so I know you're still enrolled, and not just logging on to Canvas, but completing some work. And then at the bottom here, this is just the pacing guide, so that's what the schedule there is. Okay. So now kind of scrolling down in Canvas, again, that's all the getting started tab. So hopefully all of that is clear to you now. But now this next tab is where the bulk of what you need to get done is. So this is everything that's great. So like I mentioned, you have your final project and your final exam. So to talk about the final project first, you'll see that the submit here, this is where you'll actually submit the final project. And I'm going to show you in a student view just to kind of show you what it's going to look like on your end. So you can see here that there's a rubric that kind of goes through all the questions. And then if you scroll down all the way at the bottom, oh no, not at the bottom. Where's the submit option? well. I don't know if one of you don't mind opening this and seeing if you have a submit option on your end. If you don't, that will be a problem and I'll have to fix that. So I don't see anywhere because you should be able to submit like a file on it. Let me see. Leave student view. Okay. I'm gonna see if so again, if you click submit here, there should be like a submit button where you can upload.
I
I
see
see
this.
the submit button.
Oh, good. Okay, so it's just me then. Perfect. So there should be a submit button and you can submit it. Again, you can submit it multiple times. What I would suggest you do is after you finish because there's going to be like questions for each of the 4 competencies. Once you finish the questions in competency A, I would just go ahead and submit it to me once. I'll take a couple days probably to get back to you. Hopefully I'll get back to you the same day. And I'll grade all of those. And then if any of them are incorrect, you can just go through and like just change that one. So that's the other thing to note. If you just get one question wrong, you don't have to go back and like redo the whole assignment. Just basically like if you have a Word document, just delete that question and rewrite it. So and resubmit it. So that's the other nice thing. So like when you resubmit it, like whatever you get wrong, you just have to go back and fix that. So the nice thing about doing it that way is then once you get to competency D, hopefully by that point you have A through C all 100% correct. So you don't have to like all of a sudden scramble at the end and have to redo everything. So if that makes sense. And then the other tip, please, please, please do not save your last submission for the last or second to last day of the course because that is risky because if you have something wrong, you might not have time to redo it. And that's where you really could risk accidentally getting a 14 out of 15 and, basically getting a 1.5 in the class for, a reason like that, which I do not want anyone to have happen to them. So I would say by that last week of the course, you really should be really finishing up the final project and having everything 100% complete or very close to. But yeah, so you'll submit the project there. Again, you can submit it multiple times. And then for where to find the actual questions, there's this final project template. So if you open this, it's in the form of a PDF, which I'll shoot you guys a Word doc of this too, just in case you want a Word doc where you can actually like easily edit it. But these are the list of questions. So you'll see for competency A, there's about 5 questions. Competency B, 5 questions. C, there's 4, and D, there's 6. So these are all the questions. And you'll see that competency A is all about electrical theory, so the questions all relate to that. And then part 5 wants you to explain how to use a multimeter. I just want to bring this one up just because this is the other nice thing about this course is you kind of get free creativity as well. So like if you are one that likes to type all your answers, go for it. If you're one that wants to create a video and talk about all 5 of these, you can do that as well. So if you don't want to type it and just want to like create a video, if you have a multimeter at home and like want to show how you would use it either to test voltage or current of like a battery or outlet or something, go for it. That's totally fine. I actually would highly encourage it. And maybe I'll set up a cross braining late. I'm going to do that today. I don't know if any of you have ever used cross braining, but essentially what it is it's like a third-party platform, kind of like YouTube, where you can upload it. So I'll create a cross braining for the project. So if you want to just create videos and like on your phone and just upload them quick, you can do that if you don't like to type. So I'll do that today and I'll send you all an email if any of you would rather not type and would rather talk. You can do that. So you have full creativity on however you want to do these projects. So like, for example, too, like some of these, like defining voltage, resistance, and current, it's easier for you to draw a circuit and like talk through the elements there or, whatever you want. This isn't an English class and I'm not an English instructor. So you're not going to be graded on grammar or, you know, how many words you have. As long as it's right. However, you want to deliver it to me, it's fine with me. Yeah, so these are the questions, and kind of like going forward for the next 6 weeks that we meet. This is kind of what we're going to focus on. So I'll talk through some of the quiz questions, some of the projects. I'm not going to give you the answers at least, but I'm going to really talk through them and kind of hopefully guide you to uh, get the right answer. Okay, and then the last thing I wanted to talk about, and then we'll switch gears and talk about just some of the competency A stuff. I'll save 10 minutes then for question, but the final exam is in 4 parts. So you'll see here that these are the 4 exams. So these are the ones that you also have to complete to get 100. You should have unlimited time, unlimited attempts on all of them. So what I would advise is maybe like in the next day or two, take the competency A quiz once, even if you don't know anything. And just that'll kind of test and assess like your knowledge and let you know like where you need to kind of focus your studying on. Because for the next, I think 2 weeks, I'll have to look back on the pacing guide, but actually let's pull it up. I forget what it is. But for the next couple of weeks, we're going to be working on competency A. So you might as well get started on a quiz and see where you stand. As far as like where the content is to actually learn this information, if you scroll down, you'll see that there's sections for every competency, and this is where you learn. So this is where there's some amateur modules if you want to do some simulations and learn that way, some short lecture videos. There's a couple, it's kind of broken down into sections. So this is all about electricity. These are about power. This is about using a multimeter. So of course that's going to help answer that project question. But yeah, so it's kind of broken down like that. Same with competency B. Same with competency C, and then same with competency D. So that's kind of where it all stands. And let me just look real fast at the pacing guide to see how long you should be working on competency A. So it's through part 2, week 2. So by the end of next week, so by the end of March, so starting April 1st, that's when you'll start working on part B of the project. So you have a decent amount of time to complete part A, both the final project portion and the final exam portion. But yeah, so that's basically it. Like I said, we're going to switch gears in a minute, and we have 20 minutes to start talking through some of these concepts and competencies from part A that you should learn. But I'm going to take another break because I've been talking for a long time, and just pause again and see any questions, any concerns, anything you don't like or want to discuss, or anything at all. This is the first time I think that we've kind of fully enrolled this course as a CBE. So please, if feedback is strongly appreciated. If there's anything that I went over that you don't like, feel free to let me know, and we'll definitely take a look at it. So any questions at all? All right. Well, the other thing too is you'll see there's just this instructor here. So this is where I was talking about if you want to schedule office hours with me, either virtual or in person, you can use that link and it'll schedule it, and then I'll get an email and shoot you a Zoom link. Or if you want to send me an email, and we can find time to meet. But all in all, I really hope this class you learn the competencies that you're supposed to learn and get what you're supposed to get out of it, because that's why you're here. But I also hope that it's not too stressful for you, and not too overwhelming. It's really not the intent at all. Really, the intent is to just help you be successful. And I'm here every step of the way to help you. So, yeah. And the other thing I'll note too, just because I know online courses can be frustrating when it's like, so it's not face to face, and some of you might not like that environment. But please, I'm here to be as communicative as possible with you. So, if you send me an email, I will get back to you in a day or two. If I do not, please send me another email, because oftentimes I might have just missed it, or it might have gone to my junk. So you should be getting an email back from me pretty quickly. This is my job, so I'm here to help in whatever capacity I can. Okay, so with that, if there's no questions, I'm just going to pause just again, make sure there's no questions, and then I'll start talking about competency A. All right, not hearing anything. This is good. I'm hoping. I'm hoping that means everything's clear and good. Okay, so all right. So I just want to talk through this slideshow. Again, it's competency A is all, if we reread it, it's all about just an introduction to electricity. And this is definitely like the fundamental concepts, I would say, if for any of you on that are going on to take ELT 120, ELT 126, any of those electrical courses, competency A and B are very crucial to that. So we're going to talk essentially about how electricity works, the properties of electricity, and how circuits work. So going back to this, basically, what is electricity? So electricity is just a form of energy resulting from the existence of charged particles like electrons and protons. Um, Used statistically as an accumulation of charge or dynamically as a current. What that basically means is electricity is just the movement of charges, essentially the movement of electrons. So an atom, you probably learned from basic chemistry classes, is where it's got neutral balances and positive balances in the middle, which are the neutron and proton, and then those electrons are kind of circulating it. So electricity is just the movement of electrons. As electrons carry a charge. So that's really what electricity is. When talking about a circuit, which is the pathway through which our electrons are traveling, that's what a circuit is. So a circuit is just the pathway through which electricity flows. Everything in your house has a circuit, like everywhere that is powered, it's because of a circuit, right? Like a light over there or above me right now is a circuit where electrons are flowing through that load and then back to the panel board and all of that. So essentially what a switch is this is basically a short or a simple series switch. And you can see there's a couple components here. So a switch essentially is the door. So that's what turns on and off the electricity, because when it comes to electrons, they have to have a complete closed pathway in order to light whatever they're trying to light. So you can see here that the electrons flow along this circuit, and the medium through which electrons travel is through like a wire, typically copper or aluminum. So that's where you see this outline where it's a square. That's the wire portion of this. That's where your electrons are traveling. They need to travel through a medium, right? They can't just travel through thin air to create electricity. So the electrons are going to move from one end of the circuit all the way around. And the switch, if it is open like it is now, that means the electrons aren't going to be able to move, which means that we're not going to be able to get from one end of the battery to the other, which means the light bulb or the load or whatever, which is whatever you're trying to get to be powered in the circuit, is not going to work. So when this switch is closed, like it is now, your electrons can complete the circuit and electricity is going to flow. So essentially, electrons have to have a complete closed pathway in order to, power whatever you're trying to get to power. The other thing to note here is the battery. So the battery is essentially kind of like the push and pull of the circuit. So this is what pushes and pulls those electrons through the circuit, and however strong that battery is how strong that push or pull of those electrons is. So those are just a couple terms that are important. So again, the thing I always remember about it is close equals flows. So closed, when the switch is closed, that's when electricity flows. And this is like how a light switch works, right? Or a switch in a house, that's what it is. So when you turn that switch off, what's happening, like behind the scenes, is it's essentially opening that circuit and the electrons aren't flowing, and that's where the light turns off. So yeah, Any questions on this? Again, feel free to stop me anytime if there are any questions. If I need to
Um,
re-explain things. Yeah, go
is
ahead.
there a difference between the resistor and the load?
Yes, and let me see if I have. I don't have a picture. So good question. The resistor, and we'll talk about resistance in a minute, but resistance, there's kind of three. Actually, it was the next slide. There's three fundamental terms when talking about circuits, and that is current, voltage, and resistance. So your load, again, is like the actual thing that you're trying to get powered. So then a lot of examples when they show a switch, it's or a circuit, it's just like a light bulb because that's like what the electrons are flowing through to like get powered, right? The voltage, we talk about voltage, that's the voltage of the battery. So the greater the voltage of the battery, the greater the push. Resistance is essentially the opposition to current. So you might add a resistor in a circuit in order to slow down the current. It's a way to kind of manipulate other parameters in the current. So when talking about it in electrical theory, like this class, you'll see that in weeks to come, we'll draw resistors on a circuit like this. So they are kind of like shown in like this zigzag line, and then they'll have like a value. So like I'm just gonna put 10. And then this is the symbol for resistance, it's ohms, so 10 ohms. So this is like an example of how a circuit might look. So that was a great question because it's kind of missing a resistor. When we talk about circuits from here on out, they're always going to have at least one resistor, sometimes more, all drawn like this. So it's again like a zigzag line and a 10. And again, resistors are added essentially to manipulate other parts of your circuit and are kind of vital to it. So does that make sense? I hope I answered your question.
Yeah, that makes sense. Thank you.
Yeah, of course. Alrighty. So kind of moving on, I guess we already talked a little bit about this. So these are just the symbols for those three terms. There are a couple quiz questions on it. So be mindful of that. Again, these are the three important terms. Current is, we haven't talked too much about that, but essentially current is the speed at which those electrons are flowing. So of course it's depending on voltage, how fast or how big of a push the voltage gives. So current is the flow of electrons. So it's measured in something called amperes. You might see it just as amps. And it's abbreviated by the symbol. Well, it says A, like it might say like 5A is the current, but the symbol for current is actually AI. And I always get asked why, and I always laugh and say that I guess C was taken with another letter, but I had to look it up because I didn't know the answer the first time, and it's like a Latin word for current, which is like intensity of current or something, but that's where the I comes from. If you're wondering, it's C must have been something else, so they made it I, and that's why it's I. Voltage is measured in volts, so that's pretty straightforward. So and that makes sense, right? It's like you would say like, oh, this battery is 80 volts. That's your voltage. The voltage of the battery is, or how many volts your battery is always the voltage of the circuit. And resistance, we just talked about, is measured in ohms. That's the opposition to current flow. That's what slows your current down, which makes sense to think about, right? Because like if you resist something, like you're like opposing it, right? So the resistance of the circuit. Alrighty, so voltage we talked a lot about here. It's just that push or pull that moves your electrons. So you can see here that this is just a quick picture that I grabbed. I didn't make this or anything, but just the voltage, like this is like a small little circuit. You can see here the load is a light bulb. Your battery is right here, and then the electrons are kind of flowing through that wire. So you'll see this denoted as either like 80 V or 80 volts. Of course, that number is going to change depending on what your voltage is. Current, again, is measured in amps. It's also sometimes measured in coulombs per second, which makes sense if you think about it, because current is how fast your electrons are moving through the circuit. So it makes sense that it's measured in coulombs per second because that's a distance over a time, and that's speed, right? Distance over time is speed. So that's a good way to kind of remember it. But typically you'll see it as amps. So again, it's the speed your electrons are going through the wire. It's the main thing you have to know about that for now. Finally, resistance. I grabbed this off Google just because I think it's an interesting table. It kind of shows the factors that affect resistance. So resistance, you can add resistors in a circuit, but there are a lot of factors that affect how well a resistor works. For example, you can see here length is going to impact your resistance. And this is the wire of like in your circuit. So the length of the wire is going to impact the resistance. The more wire, the greater your resistance is going to work. You can see that the larger area is going to have less resistance. Depending on what material you have, you might have more or less resistance, and also depending on if your temperature is lower or higher. You can see when temperature is higher, you have a greater resistance. So essentially, there are a lot of factors that increase resistance. For this class, all you need to know really is that one of the most important things is that you can increase or decrease the resistance in a circuit by using a resistor. So a resistor is like a physical component that you can add to a circuit to kind of slow it down. So there are a couple things that don't really impact resistance. So one thing that's kind of interesting is the strength of the power supply. So how much power you have is not going to impact your resistance in a circuit, which I always like to talk about because that's one that like you would think would. So it's just interesting that it's a lot of basically like other physical properties like length, material, diameter, the load. Those are what do impact resistance. And then we already kind of talked about this, but the higher the resistance, so the more resistance you have, the more opposition to the current, which means the lower your current is going to flow. It's important to note that if it's ever abnormally high, this can be a safety concern. It can, damage your conductors, which is the material through which your electrons are traveling, due to burning or corrosion. So, it's a careful balancing act. Okay, so the other thing I want to talk about was Ohm's law. So Ohm's law essentially is the relationship between these three terms. So voltage, current, and resistance. You essentially can calculate any of those three terms if you have two of the three. So the equation for Ohm's law is V equals I times R, and I should check on time. Okay, 6:17. Oh gosh. All right. So I'll stop here in a few minutes and we'll pick up next week. Essentially, you can calculate any of the three terms again if you just have two of the three. V equals I times R, which means that I times R, remember I is current, I multiplied by R will give you the voltage. And of course, you can do quick algebra to isolate any of these three variables, which is what I did here when I wrote these to solve for the other terms. So if you want to stand for current, or if you want to figure out what current is, you can just do voltage divided by resistance. Resistance, you can do voltage divided by current. It's also interesting to note here in the equations, you can see the correlation between resistance and current, because if we look at, I don't want to do that. So if we look at this equation here, I equals V divided by R, you can see that I is current and the resistance is on the denominator, which means the greater your resistance is, the less your current is going to be. For example, let's say that we had a voltage of 10 volts and a resistance of 10 ohms. This would solve for I, right? Because it's V divided by I. So we know this would be 1 amps, right? Because it's V divided by R, which is our resistance. 10 divided by 10 is current. So this would be 1 amp. Okay. So what happens when we increase resistance to 20? 10 volts divided by 20 ohms. That gives us 0.5. So what does that show you? It shows you that when we increased our resistance from 10 to 20, we decreased our current from 1 to 0.5. And that makes sense, right? Because the more resistance we have, the less current we have. Good question. So I'll shoot this PowerPoint in the chat if that would be good. Okay, so I'll probably do, well, let's talk through this, and then I want to make sure I save time for questions just because, like, it's still first week of the class, but we'll pick up next week on this and just continually talking about this. So this is another thing I wanted to mention. So this is a wonderful chart. If you type in Google, you can find this anywhere. Essentially and I'll give you these slides too. But essentially this shows all of the equations you would use. This P stands for power, which we're going to talk about next week. But it shows all the equations you would use if you ever needed to solve for any of these terms. So like, for example, in this green section, if you need to solve for current and you're given voltage and resistance, you would use this equation, I equals V divided by R. If you were given power and voltage, you would just use I equals P divided by V, and so forth. So this is like a quick access table where you get all the equations. Again, P is power. We'll talk about that next week. Okay, so let's just do a couple of simple examples. The quiz for competency A, or the exam portion, will have a couple questions here. So it says, what is the current in a circuit with 15 volts and 3 ohms of resistance? Okay, so we know we are solving for current. We were given 15 volts. We know volt stands for voltage, right? And we know that ohms is resistance. So we were given voltage and resistance. We need current. So if you go back here, okay, we're solving for I, right? So I again is current. I equals V divided by R. We know we have voltage and resistance, so that's the equation we'd use. So I, put that right here, equals V divided by R. And in this example, our voltage is 15 volts. So I'm going to write 15V because that's the symbol for volts. And we have 3 ohms of resistance. Okay, so 15 divided by 3 is 5, which means that our current I is 5 volts, and that is your answer. They're not volts, amps, right? So it's as simple as that. Just simple division and multiplication. And that's a lot of the questions for the on competency A quiz. That's a big chunk of it, is just talking about Ohm's law. So hopefully that made sense. And if it still is a little bit confusing to you, next week we'll pick back up. We'll do a couple other examples of finding for, voltage and resistance. And then we'll start next week talking about some DC versus AC uses and circuit breakers, and we'll talk about power a little bit. And then by the end of next week, I think you'll really have all of the information you should know to do pretty well on the final exam and final project competency A. Yeah, so with that, we saved, look at that, 8 minutes. So if there are any questions or concerns, I'm going to stop sharing. Now is your time to ask if you have any questions about what we went over, or I'll put the PowerPoint, I'll send it in an email when I send the link to today's video. So because I want to, some of these slides are a little bit blurry anyway, so I'm going to make the font a little bit bigger and modify them a little bit. So I'll keep the same wording on the slides though. So I'll send all of this today, or probably in the next day or two to you. But with that, if there's any questions on what we talked about at all throughout today, now is your time to ask. If there are no questions, you get 7 minutes back. Enjoy the rest of your night, and I hope to see you all next Wednesday, right? Today's Wednesday. Yes, I think next Wednesday. Hope to see you all next Wednesday. Thanks for logging on.
Thank you.
Yeah, thanks.